2, 1, quartiles and box and whisker plots. So at some point when you get into statistics, hopefully you might run into this, and that might be in your data management in grade 12, or maybe earlier, or maybe a little bit later, okay, depending when you are studying statistics. So I'm going to go over this by just kind of an explanation about these quartiles, an explanation of how the box and whisker plot looks like, and then I'll do an example as well so that you can see how to create these. All right, so the assumption is that you do know what a median is, for example. So that's the mean, median, and mode, okay, those central tendencies, okay. I will put up a link up above there in case you have forgotten it. Now, if you have a certain number of data set points, it doesn't matter how many you have, right? If it's a lot, then it's harder to do with something like by hand and pencil. But if it is something manageable, and that's something what I'll do is, at least for the intuition behind these, we can certainly create these quartiles and then box and whisker plots. So first of all, okay, what I'm going to make an assumption in is, my assumption is going to be that, at least for my explanation for the moment, okay, things are kind of evenly distributed across your data points. So let's say you collect your data point. And so here would be your lowest data point. All right, so it would lie somewhere in here. So that would be your lowest datum. Here is your highest data point. So this one is your highest datum. Okay. Now, if you collected all of them, you would be able to calculate your median. Now, your median would be basically, it could possibly be the middle data point if you have an odd number. But if you have an even number of data points, then you know you have to take the two middle ones and then divide it by 2 to find what that median is. So let's assume that we found our median, okay, and it is somewhere in the middle here. So here is our median. I'm going to just label it as M. Now, if you wanted to talk about quartiles, well, quarters, okay, so dividing things into 4 equal components shouldn't be that much of a grasping item for you. So if you're taking 4 quarters in general, we could take from the lowest data point to the median, and you can find the median, okay, of that first half. And if you would find that median of that first half, what you would do is, okay, so this right here, this would be your first quartile point. And so that first quartile point, I'm going to just designate it as Q1. And then you can take the second half and then find the median, okay, of that second half. And you would have found your third quartile point. Now, technically, we have 4 quartile points. So the median itself sometimes is also called Q2. Okay, so that is the median, that's the second point. And then the last highest one would have been your Q4. Okay, but we typically just simply say median, and then we have our first quartile and third quartile. So now you can clearly see that it is dividing the entire data point into even chunks, okay, of data, where what you would have is in the first quarter, okay, and ending at the first quartile, you would have, okay, 1/4 of the data points lying somewhere within there, okay, and then in the second quarter, you know, you would have your second even number of points lying in there, and third, and so on. So you can see how that works and why these are called quartiles, okay, so we have 4 different quarters. What we do is, okay, we construct kind of these box and whisker plots from all of these. Now, before I jump into that, what I would want to point out to you is that if you take your Q3, so once you find your third quartile, okay, and then you subtract your first quartile, this is going to give you a range, and this is called the Interquartile range that you have in there. Now, semi-interquartile range would have been half of that. So sometimes you hear that word, semi-interquartile, but this is your interquartile range. And it has a certain length associated with it, because clearly if you do this mathematically, if you take that Q3 and you subtract Q1, you would know what the length of that interquartile range is. Now, why do we need this? Well, this is interesting because we can create kind of our box and whisker plot from these to see where the points, okay, are lying. Where are they concentrated within? And we're interested in that kind of interquartile range, which we construct a box for. Now, this, technically, visually you understand it because, oh, I have 4 nice different quarters. But in reality, when you take real data points, it's not going to be such a nice even distribution. You'll see that Q1 and Q3 may lie, very close to the median, okay, that you have, or maybe one of them lies very close, the other one lies a little bit further. So it just tells you how things are distributed. And I'll do an example shortly. So what is this box and whisker plot? Well, the box and whisker plot works something like this. So if you have, so this is the entire, let's say, range, okay? And what you would do, I'm going to maybe switch the color here, and I will also, just so that you can see, okay, how things are lining up. So let's say, this is your lowest datum. This is, your first quartile right here. This would have been, hopefully I'm drawing these straight. This is your median or second quartile. Okay, so this right here, my third quartile, and then here's my highest data point, highest datum, okay, like so. And now if you want to construct your box and whisker plot, then what you do is the following. So so you basically put a point on your lowest datum and put a point on your highest datum. You take the interquartile range and you create a box out of that. So I'm going to create a box right here, which falls exactly, no, I didn't do that. Okay, perfect. Okay, so it adjusted for me. So let me make this like that. Okay, so here's your box. And then I'm going to have to do, okay, these whiskers, which are going to be showing those other points that are lying outside of that. And then here is, okay, my median. All right. Now I'm going to remove that black range, okay, that I put in, and that is your box and whisker. So here it is. Here is your box, and then here this right here and this right here. Those are your whiskers. Now this is, again, because it's nicely and evenly distributed, it may not look like this. Right? Exactly how it is if you take real data points. So let us take an example and try to illustrate this concept through that example. So I kind of took these, okay, so we have, are interested in maybe some hospital, and then we want to be able to see the number of IV pumps in a department. So some departments have very little IV pumps and other departments might have quite a lot of IV pumps. And now, so I have 24 data points in here. So it's an even, okay, number of data points. So we're going to have to kind of work out the median and then the first quartile and third quartile from these. So as you know, so for the median, if you're doing it by hand, it's always very useful to try to first align them, from smallest to largest, just to see where your data points are lying. So I have it basically from 0, and it looks like the highest one is 15. There's a lot of repetition in here. So let me speed up the process for you. All right, okay, and I'm going to rearrange these. Of course, you can do that on your own. Okay, I'm going to just kind of be right back. All right, so that was quick. Well, quick for you, not so quick for me. So now here is the arrangement, okay, from smallest to largest. And as I mentioned, so we have 24 data points. All right, so half of that would have been 12. So I have to take kind of the 12 and then so I have to have an even number, right, on the left and the right. Okay, so I'll take the 12 and then the 13th points, okay, within here to try to calculate my median. So that's what I want to do first. So what is my median right here? Okay, so, well, that's 8, so 9, 10, 11, 12. Okay, so that is so 12, so that would have been a 3. Okay, and it looks like 13 is also a 3, well, divided by 2. Okay, so my median is basically 3. And so notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points on this side. Okay, now my median falls right in the middle, so this would have been the half. And then I also have the 12 points on the other side. Now, if I want to find my first, so this is my first quartile, so I have to do the same thing. So I'm going to be taking the 12, all right? So now I have 12 data points in the first half. Okay, so from the median all the way to 0, my lowest datum. And then I'm going to take, so 12 points, I have to take the 6th, okay, and then the 7th. All right, so 6th and 7th, so that would have been 1, 2, 3, 4, 5, 6, so that's 1 and 2. Okay, so that would have been 1 plus 2 divided by 2, so that's 1.5 for that one. All right, so I have now at 1.5, so that means I have 1, 2, 3, 4, 5, 6 points on that side, and 1, 2, 3, 4, 5, 6 points on the other side. Now for my third quartile, okay, so if I calculate that, so I have to take, all right, so from the midpoint, so that's from that 3, okay, all the way up to the 24. So I'm taking basically from the 13 to the 24. Okay, so I can now calculate those. So I have 1, 2, 3, 4, 5. Okay, and 6. All right, so those are going to be, because I have 12 points there, so it's going to be 6 and 7. It looks like 6 and 7 is 5. So it's going to be 5 plus 5 divided by 2, which is going to be still 5. All right, so that's what I have in there. So I have 1, 2, 3, 4, 5, and 6. All right, so I have now found all of these. Now my lowest and highest, okay, data points. Okay, so that's the 0 and then the 15. When it's rearranged this way, then it's rather simple. So now creating this whisker plot, okay, so what I'll have, so this continues on in here. So what I have is the following. So here is going to be my 0, all right, okay. Now, I guess I'm gonna, I'm gonna cheat a little bit. Let me change the templates here. I want to put it as grid paper so it's easier for me to do this. All right, so I can do that. And let me shift these out. Okay, so if we start, so let's say this is 0, and let me do this in kind of fast forward fashion and be back for you. All right, so I recreated this just so that it's kind of nicely spread out there, at least by hand. And now I can plot these points. So this is going to be 0. Here is 15. Okay. Now my median, okay, so within here, so that's going to be 3. So notice that's going to be right here. That's 3. We'll put a box around there. My Q1 is 1.5, so that is actually right here. And then my Q3 is 5. So this is interesting, very interesting. Okay, so let me draw a box. I'll draw a box which is a little bit bigger. Okay, like this. Okay. So it's going to go through my median right there. Okay, and now my whiskers, okay, so this is, okay, so I can draw a whisker right here, okay, and notice the other whisker would have went all the way up to 15, okay. Now, one thing that I would want to point out, that very often what we do is, if it so happens, okay, so if I go back to our explanations there, okay, if we take our interquartile range and we know this length, so we know our length to be, so in this case, so our length is equal to, so it's Q3 minus our Q1. So our length is 3.5, I guess. And now, whatever lies outside, okay, of our length, so 1.5 times, so notice our box is 3.5. So if I take 1.5 times 3.5, okay, so if I bring this back, let's say, okay, just do it quickly, so that's around 5.25, all right? So 5.25, okay, from 5, so that would have taken us somewhere just a little bit further, okay, than 10. So if our data points lie 1.5 outside of the interquartile range, okay, so that length, we typically would say that they're outliers. All right, that they are outliers. So now for us, okay, we have data points with 15, okay, and then the next one, I guess, is 9, okay, so 9 is the last one right here. So very often when we do draw, I'm going to make this a little bit thicker here. When we draw our whiskers, okay, like this, we're going to omit, okay, the data points that are the outliers. So that 15 there seems like it's some kind of an outlier. So whatever, okay, that department's doing, they're stashing up their pumps there. Now, this doesn't always happen, of course. You know, you may just simply say, okay, well, you're not interested in kind of outliers. You think everything is kind of correct. So that whisker would have went all the way to your highest datum point. Now, if for us, okay, the way I did it is I just wanted to show you, okay, if you are interested in kind of outliers, this would have been how you would draw your box and whisker plot. So notice it's very compact towards that range around that median, okay, which is on the lower side. Okay, the other ones, okay, are a little bit spread out further, so you have more of that whisker on the right-hand side, definitely a lot less on the left-hand side there. All right, and that's how you would create these. Okay, so interpreting them, you know, looking for them, it now kind of gives you a visual plot of where that data set is lying. All right, so thanks for watching this video. I hope you found it useful. I'll see you in future ones. Bye, everybody.